All right, I want to work this cloud cover problem for you because it's actually an ambiguous problem, but here we go. The it, it, Using the numbers here that are stated, um, it says to measure the height of a cloud cover of an airport, a worker shines a spotlight upwards at an angle of 73 degrees from the horizontal. So, so here's the horizontal, and you're going 73 degrees upwards. Okay, and it hits the clouds, up here somewhere. An observer 713 meters away measures an angle of elevation to the spot of the light to be 50 degrees. Find the height of the cloud cover. Okay. Now, there is a little hint that says a similar picture can be found on page 486 of your Stewart text, but we're not using the Stewart text. Anyway, as it turns out, we are switching to the Stewart text next quarter. But it's a newer edition and it's not on page 486 and it's not number 60, it's number 66. The thing is, the other person, it never says where they are. Only it says they're 713 meters away from this person. But does that mean they're 713 meters, out here? Is this 713? So that this angle right here is 50 degrees? Or maybe this person is actually over in that direction. 713, or maybe it's completely off to the side over here somewhere. Uh, anyway, when I looked it up in the text, they actually drew the picture this way. So this is what I'm going to assume we're doing. They're looking for the height of the cloud cover, so I'm going to drop a perpendicular right here, and that's H. That's what we're looking for. That right there. So what I see here is two right triangles. I got a couple of side lengths here, X, and let's call this one Y, that they're going to add up to 713. If this person here was actually out on this side over in this direction, then this would be 713, and so maybe I would have Y minus X is 713, but right now I have Y plus X is 713. The thing is, what I got to do is I got to get X plus X and Y in terms of H so that then I can then solve for H. So here we go. I look at this triangle with a 73-degree angle in it, and I see H is the opposite side and X is the adjacent side. So I know that the tangent of 73 degrees is H over X, which lets me solve for H. No, lets me solve for X as, so I'm going to multiply and divide. So it's H divided by tangent of 73 degrees. Likewise, in this triangle over here on the right, H divided by 50 is the tangent of, no, sorry, H divided by Y is the tangent of 50 degrees. Opposite divided by adjacent, which if I solve for Y, I get that Y is H divided by the tangent of 50 degrees. So, plugging X and Y now in to here, I've got that H divided by the tangent of 73 degrees plus H divided by the tangent of 50 degrees equals 713. So then I can solve for H. So I'm going to factor out an H here and then divide by that stuff. So 1 over tangent 73 degrees plus 1 over tangent 50 degrees is 713, and when I divide it here, I've got H is 713 over all this stuff. Which, when I plug it into my calculator, gives me 622.7997. Yeah, and so anyway, I checked with those numbers against Jennifer's problem because she's the one who asked it, and that is the correct answer that WellMap is looking for. So they are assuming that these two distances add up to the full 713. Um, you know, it's completely different if you don't make that assumption. You know, looking straight down on this problem, you know, if this is where the first person is shining the light up to the, you know, I'm looking straight down from the clouds here. You know, maybe this person's over here and this is 713, and you know, so the distances you're calculating, x and y, which would be underneath there and underneath there, don't add up to 713. So there's an assumption that needs to be made, and you know, that those are lined up that way. But once you have it, um, anyway, these are the calculations. It's similar to flagpole on a roof problem. Uh, but anyway, 622.8 essentially.